Ever wondered what are the different data types for Ndarrays in Python's NumPy library? It's a question that might sound trivial, but the answer is crucial to efficient data processing. The data type you choose for your Ndarray can significantly impact the speed and performance of your computations. It's like picking the right tool for the job. Today, we will walk you through the different data types for Ndarrays and explain each one with syntax and examples. Starting off with the integer data type. An integer in the world of data science represents whole numbers. When defining an Ndarray object with an integer data type in Python, we use dtype np.int. For example, to create an Ndarray of integers from 1 to 5, we write np.array dtyping np.int. This defines an array where each element is an integer. So that's how you use the integer data type in Ndarrays. And next up is the float data type. In the world of Ndarray objects, the float data type refers to numbers with decimal points. To define an Ndarray with the float data type, use the dtype parameter in the numpy array function, like so, np.array dtype = float. For instance, let's create an array with the values 1.5, 2.5, and 3.5. The outputted array will display these values, confirming they're stored as floats. That's the float data type for you. Moving on to the complex data type. A complex data type is a combination of real and imaginary numbers, represented as a plus bj, where a is the real part and b is the imaginary part. To define an Ndarray object with a complex data type, we use the dtype keyword with complex. For instance, numpy-array dtype complex creates an Ndarray with complex numbers. And that's how we use the complex data type in Ndarrays. Lastly, we have the Boolean data type. This data type is used to represent truth values, true and false. When defining an Ndarray object with a Boolean data type, we use the dtype parameter and set it to bool. Let's consider an example. Suppose we have an Ndarray object, and we want to check if the elements are greater than 5. When we apply this condition to our Ndarray, it will return an Ndarray of the same shape, but filled with Boolean values. So that's the Boolean data type for Ndarrays. So now you know about the different data types for Ndarrays in Python's NumPy library. We've taken a deep dive into integer, float, complex, and Boolean data types, each with its unique properties and uses. Recall that the integer data type, represented as int, is used for storing whole numbers, while the float data type, denoted as float, is employed for numbers with decimal points. The complex data type, noted as complex, houses complex numbers, and lastly, the Boolean data type, marked as bool, holds true or false values. Now, why is it important to understand these data types? Well, choosing the right data type is crucial for improving computational efficiency. For instance, using a float where an integer would suffice can lead to unnecessary memory usage. Similarly, using a complex type when a float will do can overcomplicate your computations. Don't shy away from experimenting with these data types in your own projects. Python's NumPy library is incredibly flexible, and knowing how to harness its power can make your data processing tasks much more efficient. Remember, the right tool for the right job can make all the difference. In the world of data science, that tool is often the correct data type. So familiarize yourself with these tools and watch your code's performance soar. We hope you found this information helpful. Stay curious, keep learning, and happy coding.